Hello students, welcome back to my channel. So today we are going to start the chapter 11, which is pointers. Now pointers is a very important concept when it comes to programming or developing a program, right? So before going ahead and learning, let us see what are the different objectives of this particular chapter, right? So the very first one is to understand the concept of the pointer itself. Next is the usage of pointer, how we are going to use it. Once we understand the pointers, how are we going to use it? Next, the role of the pointers in arrays, strings and structure. So how we are going to use this particular pointers in arrays, strings and structure. Then we are going to learn about concept of dynamic and static allocation of memory. So what is this dynamic allocation of memory and static allocation of memory? Relationship between the pointers and functions. If at all we are going to use a pointers and functions, so what is the relation, how we are going to really use it? And the last point is we are also going to learn relationship between pointers and objects. Objects we have already learned. Object comes under the classes. So classes and objects. So if at all we are creating an object of a class, now what is the role of a pointer when it comes to the objects? So these are the main things which we will be learning. Okay. So in today's session we will be learning basics about pointers. How are we going to define them? What is the use of what is the use of different kinds of operators which we are going to use when we are using the pointers or declaring the pointers, right? So before going ahead, what is the advantage of pointers? The first thing is it is possible to write efficient programs. So why is that? Now, before explaining why, let me just tell you what is this pointers exactly is. These pointers are nothing but a variable which always holds the address of another variable. Okay, remember this. Pointers are the variables which always holds the address of the variable. We already know the different types of variables, isn't it? We declare them using a data type and usually we hold values in them. For example, if at all I say int a and I will say 5, this a is nothing but it is holding the value 5. Now, similarly, so like we have variables, we have pointers, they are also variable, but only difference is that instead of holding some value, we always hold the address of another variable, right? So pointers are the variable who always hold the address of another variable, which means suppose if I have declared int a, just like that, how I have declared here, whenever I declare, what happens, a memory gets allocated and whatever the value I'm storing gets stored in that particular memory, isn't it? Now, if at all I am declaring a pointer to hold or the point at this particular variable, then what it does is it is going to point at this variable. For example, if 203 is the address, this 203 is where, that is what the value my pointer is going to store. Okay, so we are going to learn them in detail. Just a basic introduction I'm giving it to you here. So just remember that pointer is a variable, okay, like a regular variable, but only the difference is that it always holds the address of another variable. It doesn't hold any other content, but the content what it holds is always the address, okay. So now, so when I'm directly accessing, which means I'm holding the address, means I'm having a direct access into the memory, isn't it? Which means I can access the memory directly. So that is where I'm saying it is possible to write efficient programs. Why? Because I am able to use the memory efficiently. Okay. Memory utilization. Memory is utilized properly. Again, the same concept. Since we are directly accessing the memory, we can utilize it efficiently. That is dynamically during the execution of the program itself. I can use the memory, allocate the memory, deallocate the memory, right? Dynamically allocation and deallocation of the memory, that is what I said just now. So dynamically allocation and deallocation, what do you understand by that? Now when I say the word dynamic, it is nothing but something, a word dynamic, a person is dynamic is nothing but something which, you know, according to situation can change. So in case during the runtime of a program, if I need memory, which dynamically means that I am able to get the memory. When I say static, it is nothing but it is fixed. If it is static, it is nothing but fixed. But when I say dynamic, is nothing but which can be changed. Okay. So using the pointers, I can dynamically allocate or the other way, that is opposite, deallocation of the memory is also possible. So this also becomes one of the important advantage. Easy to deal with hardware components. Okay, since we are directly accessing, it is easy to deal with the hardware component. Establishes communication between program and data. So these are the very important advantages of using pointers. Now let us go ahead and learn how we are going to declare. So before that, let us briefly understand how am I going to represent. A memory is represented, isn't it? So what is the meaning of memory representation? So how a memory, we know that all the computer systems will have memory, isn't it? How they are going to get allocated or how they are going to get accessed. Now, whenever I declare something called as int a, let me use the same example. We know that the integer data type always takes 4 bytes, isn't it? Some system might take 2 or some latest systems always take 4 bytes. So what is the meaning of that? That I'm going to occupy the 4 bytes of memory for this particular variable, isn't it? So this entire thing is going to become a. So now I'm sure there is some for each byte. Since I have 4 byte, I know that for each byte there is some address, right? So for example, if I'm starting from 200, it is 201, 202, 2042. So totally I'm going to have 200 to 204. Up till that it is going to be occupied by A. That is the variable A. So when I say a memory representation, we usually say that the memory we represented something like this pictorially. Okay, so you can see in your textbook also it is mentioned. So if at all I'm saying 1 2 3, so this is nothing but the different bytes we are going to use. So if I say 1 KB, 1 kilobytes of memory, it is nothing but 1024 bytes of memory, isn't it? So this 1024 bytes of memory, if I'm representing, how can I represent? From 0 up till 1023. So this is nothing but each byte. This is 1 byte, 1 byte, 1 byte, 1 byte, up till how many bytes? 1023 bytes, isn't it? So 1 kilobytes can be represented something like this. So when I say, whenever I am declaring int a, it is nothing but it will occupy how many bytes? It is going to occupy the 4 bytes. That is, it is going to occupy these 4 bytes. So this becomes my int. This entire thing is going to be allocated to a particular integer variable. Similarly, if I am calling a float, for float also, float if I am saying 4, right? For character if I am saying 1 byte. So what happens for character? I am going to represent or allocate this memory, that is 1 byte of memory. So this is nothing but a memory representation. Remember that in memory we always use the byte concept. Now 1 byte is nothing but 8 bits. So these bytes are allocated according to the data type we are using, or however we are declaring the variables. For example, if a variable is declared as integer, then I am going to occupy 4 bytes. Similarly, arrays, when I am declaring int array of 5, what happens? So I am having integer is nothing but it takes 4 bytes, and I am having 5 array of 5, that is I am going to represent, usually we represent array something like this, isn't it? 1 2 3 4 5. So I have 5, okay, memory which is been allocated to integer. So which means each of them have 4 bytes each. Okay, 4 bytes each, 5 memory allocation. So which is nothing but 4 into 5. 20 bytes of memory has been allocated for this particular array. So this is what a memory representation means, right? So understanding this is important because we will be talking about pointers where we are talking all about the accessing of the memory. That is why this concept, understanding this concept becomes important, right? Now let us see what is a pointer. Now pointer is a variable that holds the memory address, usually location of another variable in the memory. Okay, so this is very important definition, students. This I explained. So what is the meaning of that? Pointer is a variable. Remember, it is a variable, but only difference is that it holds the memory address, usually the location of another variable in the memory. That is how it is different from the other variable. So how am I going to declare it? So declaration part, this is the syntax. I'm going to have data type, right? So I will have a data type. It can be int, float, character, double. Then I'm going to use a operator, something like this, which is a star operator, and the variable name. The rules what you will follow in order to declare the variable name is similar to the normal variables, but only difference. This is a normal, this is how we represent, isn't it? Usually we will have our data type, then space, I will have my variable name, semicolon. Here only difference is that I'm going to use operator star, which will tell me, or which will tell the compiler that this particular variable is of type pointer, and it is going to hold the address of any variable. So see here, variable name is the name of the pointer variable, okay, any name which you wish to give. Star indicates that it is a pointer variable. So this is the syntax. You will have data type, star, and variable name. So this is the definition and the syntax for declaring a variable. So once I declare a variable, how am I going to assign the value? So see here, we can assign the address of the variable to the pointer variable as follows. So here you will see a special symbol called as ampersand. Now what is this ampersand? This represents the address of this particular variable. Now I know that pointer is a variable which holds the address of another variable. Now what am I doing here? As you can see, I am declaring a normal variable of type int whose name is num, and then I am assigning a variable 25. So what happens? I am allocating a memory, okay, whose name is num, then I am storing the value 25. Next what I am doing? I am declaring a pointer variable whose name is iPointer, isn't it? So I have a pointer variable whose name is IPTR, right? Now what am I storing in this IPTR? As you can see here, IPTR is equals to ampersand num, which means suppose if the address of this particular variable was 200, then here I am going to store 200. So whenever I say iPointer is equals to ampersand num, what this does is this particular symbol will access the address of this particular variable, and then it is going to store it over here. So that is what happened. The address of this variable is 200, and that is what has got stored here. I hope this is clear. So what is the syntax in order to store the value in a pointer variable? It is nothing but you must already should have a variable which has been declared, right? That value I'm going to use the symbol ampersand and store the address in my iPointer or a pointer variable. So three things are important. Declaration of the variable whose value has to be, or whose address you are storing has to be declared first. Declaration of the pointer variable is important. Once these two variables are declared, now all I can do is just use the ampersand symbol and store the address of the variable in the pointer variable. I hope this is clear, right? So let us see the symbol, each one of them one by one. So the very first one is our ampersand symbol. So what is this? This is a unary operator. Remember, a unary operator is an operator which needs only single operator, isn't it? Single operators to use, as in, since I'm using only ampersand and one variable, it uses only single variable. Usually if I say plus or minus, these are all binary operator, as in I need a plus b. I need two variable in order for plus to perform. But when I say unary, it is nothing but uni. It needs only one operand, isn't it? So for example, if I am saying ampersand a, what happens? This ampersand will access the address of this particular variable. So when I say unary, remember it requires only one operand. If it is a binary, it requires two operand. If it's a ternary, it requires three operands. So what kind of a operator this particular ampersand is? It is a unary operator. And what it does, it returns the memory address of its operand. That means if at all I am writing ampersand a, it requires the memory address of its operand. So this is the operand, okay? For example, the same example, if you can see, int num, I am declaring a variable and assigning the value. I am declaring a pointer variable, okay? Now to put the value into the pointer variable, I am using the ampersand symbol and using the variable name. Now the variable address is going to get stored in the pointer variable, right? Okay, so this is also this ampersand is called as a address of operator. Okay, this ampersand symbol is called as a address of operator. The next one is pointer operator or indirection operator. The star what we use along with the pointer variable, it is called as a pointer operator or indirection operator. So what is this? It is the complement of ampersand, remember. Okay, it is also a unary operator, which means it requires only one operand. It returns the value of the variable located at the address specified by its operand. So what it does, since it is storing the address, it returns the value of the variable located at the address specified by its operand, right? So for example, if you can see, the same example, that is, I am declaring a integer, normal integer, then I am declaring the pointer variable, and then I am declaring the I am assigning the value over here. So what is stored in iPointer now? iPointer, it is nothing but it is storing the address of num. For example, if number was stored in 200 just like before, so it is storing 200. So what it's saying, it returns the value of the variable located at the address. Okay, so it is going to return the at the address where it is specified by the operand. Okay, so this is the operand. So when I say star pointer, so this is the operand. So what is this storing? This is nothing but it is storing the address of another operator. So this is what the meaning of the pointer operator or indirection operator. Now let us see one sample program. So in this program, what we are doing is we are declaring a variable and then just trying to find out what is the output we are going to get. Okay. So see, it's a very simple program. I'm declaring a normal integer variable, okay, then a pointer variable and another integer variable. Now the var variable, I'm assigning it the value 3000. Pointer variable, I'm storing the value of var. So what is going to happen? I'm going to allocate a memory integer and I'm storing 3000 in that, and the name of this is variable. Okay, some address I have, suppose I'll say address 1. Okay, this is the address of the var. Next, I have declared another variable called as val. Okay, and am I going to store any value here? No, I'm not going to. Pointer is equal to ampersand, val is equal to star pointer. Okay, now let us understand this. So this is clear. I hope that variable I'm declaring and I'm holding the value, that is storing the value 3000 here. Pointer is equal to ampersand var. So what is going to happen? Pointer is another variable which is being declared. What I'm going to store here? Address of var. So what am I calling it as? It can be any address. Now this address depends totally on your system. Okay, it will vary from system to system, whichever memory is getting allocated. So that is why I'm just taking a value as address 1. So whatever this address is going to get stored in the pointer variable, isn't it? So that is the content of this particular pointer variable. Now see here, I'm saying val is equal to star pointer. Now when I say star pointer, a variable, some variable is equal to star pointer, I know that val is not a pointer variable, so it doesn't hold the address. Now whenever I say star pointer, what is going to happen is we are going to access the address and I'm going to go to that address, and whatever the content is there, that I'm going to store in val. Okay, understand? val and var are the normal variables. Pointer is holding the address of var. Now when I say a val is equal to star pointer, the content of the pointer, which is of course an address, in that address whatever the content is there is going to get stored in the another variable. That is, the content of pointer is address 1. In the address 1 I have the value 3000. That 3000 is going to get stored in the val. Now what we are going to do here, we are going to print all the values, that is value of var, value of pointer and value of val. So to see the output, value of var is 3000, correct? Okay, value of pointer, as you can see, whenever this was executed in some system, this is what the output, this is the address value. Okay, usually we will say 203, 204. Usually we will just to give an example, we use simpler numbers, but this is how addresses are represented. Okay, so this is the address value. Now value of val is nothing but the content of that particular address, that is again like we said, which is 3000. Okay, I hope this particular program is clear. So that's all in today's session, students. We have learned what are the objectives of this chapter is going to be. We have seen the definition. We have seen the different operators which we are going to use in order to declare a pointer variable, also to access the address, and we have also seen a sample program. Okay. Please practice this, as a pointer is a topic which can be quite confusing for few students, but it is a very simple one, yet it is a very important concept, right? I hope these videos are helping you all in your preparation. Thank you for watching. Keep learning.